So square root of 48 is 16 times 3, and the square root of 27 is 9 times 3. So I'm looking for perfect squares. Square root of 16 is 4. So when I pull it out of the square root or take the square root, it becomes 4 root 3. And the square root of 9 is 3. So that becomes 3 root 3. So 4 root 3 plus 3 root 3 is 7 root 3. Moving on, here I'm looking for perfect cubes, and the perfect list of perfect cubes. Here's a reminder of what they are, the first 4 at least. So I recognize that 27 goes into 54 twice, and 64 goes into 128 twice. Now the cube root of 27 is 3, and the cube root of 64 is 4. And 3 minus 4 is -1 cube root of 3. Now, or I could write it without the 1 coefficient and just a negative out front. But I do need the cube root as part of the answer. All right, looking for fourth powers. 1 to 2 to the fourth is 16. 3 to the fourth is 81. Those are the first 3, so let's see what we can do with that. Well, 5 doesn't divide evenly by any of those, so I'm just going to leave that as is. And 3 halves, 320 is divisible by 16, so it's 16 times 20. Now 16 is a perfect fourth power. It is 2, so simplifying I get 6 fourth root 5 minus 3 halves times 2 times the fourth root of 20. And 20 doesn't divide evenly into by any of these, so I know I've come as far as I can in that under the radical. These will cancel, and I'll end up with 6 and 3 fourth root 20. Now it's very tempting to try and do something more with this, but these are unlike terms, so this is the final answer.